So we're talking about triangle proportionality. Let's get into a couple or easy one as far as setting up a proportion, and then talk a little bit more in detail about specific types. So this first one, triangle HIJ, is similar to triangle KLM. First thing we need to do is make sure that we label our angles to be in the same spot. So H and K are both in the first position. I and L are in the second position. And then M and J are in the third position. So we know where our angles are. That's going to help us set up our proportion because our sides have to correspond. So when we're setting this up, okay, we have this side over here on the right between our red and our blue angles. So between our red and our blue angles is over here. We also have a side between our dark and our blue angle, okay, so that goes right here. So if I'm solving for side MK, I need to set up a proportion and able to do that. 20 and X go together, and 11 and 34 to go together. There are a couple different ways we can do this, and we'll talk more in depth later, okay? But I can set up a proportion that says 20 over X equals 11 over 34, or I can set up another proportion that says 20 over 11 equals X over 34. The big thing I need to do when I'm coming up with the proportions is what goes together, what is related to each other. So 20 and X are related to each other because they're in the same position, just like 11 and 34. But 20 and 11 are also somewhat related because they're a part of the same triangle. So notice we've got those scenarios, okay, where 20 is over X or 20 is next to X if we're looking at the right-hand side, okay? 20 is next to X or 20 is over X, just like 20 is next to 11 or 20 is over 11, okay? So when we're setting those proportions up, that's going to be helpful information. And then solving a proportion, I'm going to do the same thing no matter what. I'm going to cross multiply and divide. We haven't done this in a while, but we're going to cross multiply and divide. Notice either way we do this, no matter how we set it up, we're going to be going 11x equals 20 times 34. And then I can solve it all the way down. 20 times 34 equals 680. That equals 11x. And then to solve, I'm going to divide both sides by 11. Therefore, x equals 680 divided by 11. I get 6.818, 61, 0.818, told us to round to the nearest tenth. So there's our answer. Now, that's a basic proportion. We talked about our basic triangle proportion. We've talked very much in depth on that. If you have questions on that, we've got to be able to set up proportions. But once we set them up, we should be able to solve fairly easily. Now, getting into a little bit more detail, okay, this part asks us to, we're getting into some different types of theorems, different situations with similar triangles. So this first one says, use the figure below to label each of the vertices on the two triangles that are to the right of it. So we have triangle A, I'll use smaller, A, D, E. We have A, B, and that is a C right down there, okay? So A, D, E, and A, B, C. Now we can go a little bit further. A goes with A, D goes with B, and then E goes with C, okay? When we set this up, okay, it says now fill in the extended proportion. Okay, whole triangle is similar to whole triangle, or pieces are proportional pieces. What does that mean? Okay, we have over here AD. Let's start with AD okay, is over here on the left-hand side. AD is similar, okay, to AB, okay? So I'm going to put those across the top. And then AC is similar to AE. I'm going to put those on the bottom, okay? However you want to do these, I don't really care. You could set up small over big, or you can set up in this case, we've done our small triangle on the left-hand side and our big triangle on the right-hand side, but you could also flip these, okay, and make it small over big. However you want to do that works totally fine. You've just got to make sure that you stay consistent. Either way, you're going to have A times D, AD times AC, excuse me, and AB times AE, okay? So however you want to do that, in this case, we did small on the left side and big on the right side. Okay, the other scenario is we can do on the right, small AD is the small, AE is the small, and DE is the small, okay? We have AD went with AB, AE went with AC, and I'll go on ahead and write that in orange, and then DE goes with BC. And I'm using those scenarios that they're not really congruent, so I probably shouldn't be doing that because I don't want to confuse anybody, okay? But I did want you to be able to see what goes together. So I'll outline that actually a little bit better. So AD and AB, those sides correspond. We had AE and AC, and then we had DE and BC. So those sides go together. Okay, we have small on top in this scenario, big on bottom. Those are a couple different ways to set up these proportions. But ultimately, what we're looking to do is saying that if in this particular case, okay, and this works because we have parallel lines here, because DE and BC are parallel. If the segment is parallel, DE, to one side of a triangle and intersects the other two sides, then the triangles are proportional. Okay, so because we have parallel lines right there, we can say that we have proportional triangles and solve them just like we did on the top left. So let's take a look at that right here. Big thing, draw our two separate triangles. So we have BDE with 8 and 10. We also have BAC. Okay, now notice this is X. This side is not 14. AB is not 14. Okay, AB is going to be 8 plus 14. 8 plus 14, which is going to be 22. And now I can set up my proportion. Okay, I've got my dark blue right here on the left. I've got my red on the bottom. And however you want to do it, 8 over 22 equals 10 over x. I'm going to cross multiply and divide. So cross multiply and divide. So we end up with 22 times 10 equals 8x. We'll go on ahead and multiply 22 times 10, which is going to be 220, equals 8x. Divide both sides by 8. X equals 220 divided by 8, 27.5. Down here, very similar. Go on ahead and redraw our triangles, which is going to help us tremendously. Okay, let's go our big triangle, Z, Y, X. XYZ, and we know that that's going to be 28.2. This side's going to actually be 6 plus x. We also have a smaller triangle, TYU, that has 6 and 4.8. So now we compare. We'll make this our blue side. We'll make this side over here our red side. So we'll go blue over blue, 28.2 over 4.8 equals 6 plus x over 6. I'm going to cross multiply, and I will cross multiply over here. So we have 28.2 times 6 equals 4.8 times 6 plus x. Okay, what we can do now is we can multiply 28.2 times 6. That's going to equal 169.2, and then we distribute 4.8 times 6 equals 28.8 plus 4.8x. Now I'm going to subtract, because I want to get 4.8x by itself. So subtract 28.8 from both sides. 169.2 minus 28.8 equals 140.4. And that's going to be equal to 4.8x. Excuse me. And then we can go on ahead and divide both sides by 4.8. We're going to get 29.25. That one was a little bit more detailed just because we had that expression 6 plus x in there. But as you can kind of tell, as long as we can get our triangles set up and we can figure out what goes where, setting up the proportion, we got to get used to cross multiplication and division, or cross multiply and divide. But once we get through that, shouldn't be too terrible.